We continue. When the same consequent, okay, if you have a rule where you have the same consequence obtained as a result of execution of two or more rules, then the individual certainty factors of this rule must be merged to give a combined certainty factor for a hypothesis. If you have more than one rule, we give the result the same hypothesis. So these all rules that we fire require we need to merge, we need to combine the certainty factor of each rule which we fire the same hypothesis. We suppose the knowledge base consists of the following rules. So we have if A is X and then C is Z. And then we also have if B is Y and C is Z. So what certainty should be assigned to object C? Object C is the hypothesis having the value Z if both rules are fired in situation where both rules are fired. So what is the hypothesis certainty factor of hypothesis C being believed with the action of Z, which have a value of Z. So this is just by the common sense. Okay, suggest that if we have two pieces of evidence, okay, A where it is X and B it is Y, is not this is a different rules from different source, O1 and O2, which support the same hypothesis C Z. Then the confidence in this hypothesis should increase and become stronger than if only one pieces of evidence that have been obtained. That's why when you have more number of rules being fired, it is by common sense means that the hypothesis rule that we fire which is the same with the same value that should be stronger. So based on this statement or based on this observation, then we can calculate the certainty or the merged certainty of the rules that we have the same hypothesis. So the merge, the combined certainty factor for the rule number one, rule number two, it depends on the function. Okay? And this function actually, the value will be certainty factor 1 you plus by certainty factor 2 multiplied by 1 minus certainty factor 1. If the certainty factor 1 and certainty factor 2, both of them are greater than 0. Okay, and then we use this equation if the certainty factor of 1 is less than 0 or the certainty factor of 2 is less than 0 as well. But we use the magnitude while we are calculating the second function. In the third function, the certainty factor 1 plus certainty factor 2 multiplied by 1 plus F1. In the case where both of the certainty factor is less than 0, means that it is empty. Okay, so you can look from here, means that when you combine the certainty based on the observation, is going to be increased. The strength is added. The certainty factor of the combined will be greater, is much bigger than individual certainties. Yeah, this is the certainty factor. Confident in the hypothesis H established by rule 1. The certainty factor confident of hypothesis established by rule 2. This is only the magnitude. Okay, we only take the magnitude only. Okay, that is the sign. Okay. So actually, certainty factor is actually provide a practical based on how the when we go down back observe the using the certainty factor actually give the back practical more practical to the human thinking alternative to Bayesian reasoning. Okay, the heuristic manner of combined certainty factor is different from the manner in which they would be combined if they were probabilities. So that's why it cannot be proved in the mathematical. The certainty theory is not mathematical law, but does mimic the thinking process of a human expert. It is not, we cannot prove it in the mathematical how it come into certain decision, but more on how the expert give the reasoning. If we compare with the Bayesian reasoning and the certainty factor, where the Bayesian reasoning actually based on the probability, the technique to deal with inexact knowledge and random data, and actually it works well in such areas such as forecasting and planning. Since in forecasting and planning, there were statistical data is available and accurate probability statement can be made. If you have statistical data and probability, then you can have a more accurate probability when you came into reasoning. Nevertheless, actually, in many areas of possible application expert system, reliable statistical information actually is we don't have, it's not available, or we cannot assume that conditional independence of evidence. So as a result, many researchers have found the Bayesian method is actually unsuitable for their work. Okay, for example, how many certain diseases, rare diseases, uh, regarding, for example, the heart diseases where it's rare. So it means that you cannot get a lot of data, statistical data regarding that particular diseases. Okay, so in that case, certainty factor to be applied to the expert system is much more suitable. So this dissatisfaction motivated the development of the certainty factor theories. So that's why people use the certainty factor. Although the certainty factor approach lack of the mathematical correctness of the probability theory, but in some cases it outperformed the subject Bayesian reasoning. Uh, that's what I mean by in such area, especially in diagnostic, because we have uh, less number of the data to be calculated for probability. Certainty factor are used in cases where the probability are not known. Okay, it is difficult to get, or are too difficult or expensive to obtain. Okay, certain data, it is quite expensive to get the data. For example, when you want to use, certain measurement tools, you get the data where it really expensive, then it's difficult to obtain it. So the evidential reasoning mechanism can manage incrementally acquired evidence, the conjunction and disjunction of hypotheses, as well as evidences with different degree of belief. This is the advantage of the certainty factors. A certainty factor approach also provide better explanation of the control flow to a rule-based system. Okay, but in some cases, the Bayesian method is likely to be most appropriate if you have a reliable statistical data. So the knowledge engineer is able to read and the expert is available for a serious decision analytical conversation. Okay, much more easier to make a decision and analytically if you have a data. In the absence of any of specific condition, the patient approach might be too adversary and even biased to produce a meaningful result. Okay, so in this case, it's much more easy, much more suitable to use the certainty factors. Okay, now we complete the expert system. Okay, we are going to